All right, guys. Here we go. So, most of you have this already. Don't forget, tomorrow at lunch, I'll be there at Thursday. Be here in the mornings also. And so when we look at this, I've given you guys. You guys should have these ones done for today. You had the opener yesterday. Uh, we're looking at asking questions on the example. Not many had questions. We're working on this. Really look at 45. I'll go over that one in class also. And then we had our weekly assessment today, and we're right here about linear programming. And we're working on that video. So tomorrow, the whole plan is that you are ready to go for an opener. We're gonna grade the weekly assessment, and we're gonna talk about the in-class example, and then kind of work our way through. And then tomorrow on your own, sometime you need to watch the video on variables in systems with 3 variables in them. All right, so let's get this thing going. Okay, linear programming. It's also known as linear optimization. All right. So linear optimization or linear programming. Uh, the idea is that linear just means it's all straight lines, and the idea of programming means we are testing something. So that's the idea behind programming. Okay. And the reason we call it linear optimization is our goal is to optimize the math. And what I mean by optimize the math is uh, these are really complex systems that have to do with like maybe business, maybe engineering. So those of you that are going to be engineers or business majors, this is kind of a gateway concept where you're gonna work your way into it. So business, engineering, some computer science stuff, but really a lot of business applications. And now they're talking about uh, because we have so much data, uh, like social stuff that has to do with the pandemic, medical, different things like that. So, what linear programming is, okay, is basically, we'll just call it a set of inequalities. Let me do this in a different color. A set, supposed to be a different color. There we go. A set of inequalities. Probably spelled that wrong. A set of inequalities, right? Uh, and those inequalities, uh, a set of inequalities that represent, whoops, let's try that one. Rep. Wow. I'm just going to try this one more. I guess R's are really tough on me today. Represent. They're going to represent constraints. What I mean by constraints, let's talk about railroad. I don't know why. I'm talking about railroad companies. To have maximum profit, they have to take into account gas. They have to take into account uh, freight. In other words, how many boxes they're going to get on there. They got to take into account their employee costs. And they got to take into account repairs. So each of these is considered a constraint, which is like an inequality. And those inequalities have constraints on how much money the railroad makes. So we're tying the math into actual everyday problems that are probably a little bit too big for us in general, like figuring out the gas, all those different things. But it really just is a system of inequalities that we can use the calculator for. But just remember, the constraints are, I mean, you can think of anything, computers, uh, teams that professional baseball teams, constraints are just things that are limiting their profit. Let's just keep it to business so we can talk about profit. So fast food, cost of the food, cost of electricity, cost of water, cost of rent, those types of things are constraints in the way they make a profit. So when we're optimizing or doing linear optimization or linear programming, we're looking for maximums or minimums to maximize our profit. So that's kind of the idea behind it. So let's just talk about real quick. So if I get an inequality, let's just say it makes a triangle, and that's supposed to be it's not supposed to be curved, and I shade the inner region. We talked about this the other day in class. I have to find the vertices here. In other words, I've got to find out where they cross. So I need what's called the vertex, or if there's more than one, they're called vertices. And bounded, this one's bounded. So bounded means it's boundaries on both sides. And then if it's unbounded, it may be something that looks like this. Let me do it in a different color. Unbounded means one of the sides, that's supposed to be a different color. Apparently I can't do that very well. Let's say we had 3 lines like this, right? And the shaded region was this one. This one's unbounded. This one's unbounded because there's nothing stopping it here. So this one would be unbounded. So there's no, sorry, let me write that over here. This one's unbounded. So this one's unbounded. All right. So how do we solve systems of inequalities and the calculator? So remember what we're looking for is we're looking for these vertexes here. And we're going to use the calculator. To find the intersection. This is what we've been working on all week long. Intersection. So we're going to use the calculator to find the intersection. All right. So I'm going to do an example here real quick, and then we're going to talk about we'll do another one tomorrow. So I'm going to give you this one. It's example 1. This is 3 less than y, which is less than 6. And then we're going to do y, which is less than 3x plus 12. And then we're going to do y, which is less than negative 2x plus 6. Okay. And then we have one new piece. The function, do this in a different color. The function of x and y, and that's going to equal 4x minus 2y. So these red are the constraints. These limit. So constraints, remember, constraints are what we call limits. These limit the function. That's an f function. These limit the function. Okay, so these are constraints. These limit the function. So inequalities limit things. And then we're going to test this blue one. So I will go to shapes real quick. And if you graph this on your calculator, you get this. Oops, that's not the right shape. There we go. You get a graph that looks like this, that goes across here and goes across there. And it's going to come down like this. And it's going to come down like this. Like that. Okay? And the shaded region is in between. Whoops. Let me get rid of that. Go to drawing. The shaded region is everything in here. Okay? That's the shaded region. Now, what I want to draw your attention to is this right here. So if I was to draw let's do it in a different color. If I was to draw an X and Y intercept, this is kind of going through like this. Okay, and then it's way down here like that. Okay, so this is my X and Y intercept. This is my X. This is my X. And this is my Y. Okay. So we'll do this in class using the calculator, but I want to, this is the shape you get once you put it into the calculator. This is my constraints, and we're looking at these values here. Now, this line right here is this half right there. So if I look at this halfway, I get 3 is less than or equal to y, or y is greater than 3. So if we remember right, this is a straight line at 3. So 1, 2, 3, and we draw a straight line. Now, if I do this one in a different color like green, the other half of this is y is less than 6. That's this guy. Y is less than 6, which means that's at 4, 5, 6. I know it's not to scale. Sorry, guys. And so y is less than 6. So this is actually 2 lines. And then this graph here would be this one, and we're going to shade below it, and then this one here is the other one. And so we get this shape here. And remember, we got to find the vertices. So we're going to use the calculator to find the vertices. So if we use the calculator to find the vertices, and again, we're going to do a little bit of this in class also. So if you use the calculator to find where these cross, you get 2 points. This one's -2 and 6. This one is 0 and 6. And then this other one here is going to be, oops, no, that's not right. -2 and 6, 0 and 6. Oh, yeah. This one's going to be -3 and 3. And the other one is going to be, let me do the math here, 1.5. Oops, let's go backwards. 1.5 and 3. That's supposed to be a point. Sorry, guys. It's supposed to be a dot. 1.5 and 3. So I have 4 places they intersect with each other. Now, all I do is this, guys. And again, we're going to talk about this tomorrow. I take F. And I write it out. Let's say, 4 times. And I do F, and I write it out again. And I take F, and I write it out again. And guess what? I do it again. And I'm leaving X and Y out on purpose. Okay? So I just rewrote this without the X and Y in there. Okay? I did it 4 times because I have 4 vertices right here. I have 4 places they intersect, or I have 4 vertices. A vocab word. So I just take a vertice. I'll just take this one right here. I'll go back to the color I was in, and I'm going to plug in -3 and 3. -3 and 3. And that's going to equal Negative 12 minus 6, it's negative 18. Okay? And then I'm going to plug in, let's go up to 1.5 and 3. And so I plug in 1.5 and 3. And when I do that math, I get 0. And then I'm going to plug in negative 3 and 3. And I put in negative 3 and 3. So negative 12 minus 6, that's negative 18. Oh, something's wrong here. What did I do? Negative 3 and 3. No, I did that one already. That's up there. No wonder. Let me go backwards. I missed. So negative 2 and 6. So negative 2 and 6. So that's negative 8 and negative 12. Is that negative 20? That's negative 20. And so then I have one more to do, which is my 0 and 6. Put 0 in, do 6. This becomes 0. Negative 2 times 6 is negative 12. And so I end up with 4 values here. So what do I do with those 4 values? It depends what they're asking. So the largest number here is 0. So this is my maximum. This is my maximum at 1.5 and 3. And negative 20 is the smallest one. So this is my minimum at negative 2 and 6. So we're using inequalities. We're finding where they intercept. We are shading the regions we need. And then this is called, oh, by the way, this is called the feasible region. So this is feasible, and that is probably not coming in very good. Let me write it over here. It's called the feasible region. And we'll talk a little bit about that tomorrow in class. This is called the feasible region, and it's where the feasible region is where the solutions lie. It's where the solutions are. Okay? So these are the solutions, and then those solutions give me a maximum or a minimum. Lots of information in this one video. This is just to introduce the pieces, and we will talk about this tomorrow and do one more in class together. So we'll see you then, guys.